Hello everyone, it's Daniel from Factory and welcome to my new video, implementing authorization with OpenID AuthZEN and Okta FGA. In this video specifically, I would like to talk about different approaches to implement authorization. I would like to talk about OpenID AuthZEN working group that is focused on authorization standardization, and also I would like to talk about Okta FGA or Fine Grained Authorization, which is the solution that enables you to implement granular authorization within your applications. So let's start. Before we jump into some technical details, it's good to remind the difference between authentication and authorization. So authentication is the process of verifying the identity of a user. It answers the question, who the user is. Authorization, on the other side, is the process of determining what an authenticated user is allowed to do. It answers the question, what can user do? Now, when it comes to authorization, there are some challenges and issues, which I would like to explain. Probably you are familiar with OWASP Top 10 for web application security. It's like a project that provides the list of known vulnerabilities and how to prevent them in web applications. And there is also OWASP API security project that provides a list of top 10 vulnerabilities specific to APIs. And right now I would like to focus on some of those vulnerabilities related to authorization. Let's start with broken object level authorization. It's security flaw where an application doesn't properly check whether a user has permission to access a specific piece of data. This means that if someone knows or guesses the unique identifier for an item, they can access it even if it belongs to someone else. Example: suppose you have an online banking application and you want to check your account balance. You send a request to the bank server with your account ID, like get/accounts/12345/balance, and then the server should check if you are the owner of account 12345 before giving you the balance information. If the server doesn't properly check and you change the ID to 12346, someone else's account, you might be able to see their balance too. And that's a big problem related to authorization. Another vulnerability from the list is broken authentication. Security vulnerability where the methods used to confirm a user's identity are flawed, allowing attackers to take over accounts or bypass security checks. This can happen when passwords, session management, or authentication mechanisms are poorly implemented or misconfigured. Example: there are multiple examples of this type of vulnerability. Some of them are no validation of the authenticity of tokens, accepting unsigned JWT tokens, no validation on JW token expiry date, or using plaintext weakly hashed passwords. Broken object property level authorization is a security issue where an application fails to properly check if a user has permission to access or modify specific properties or fields of an object. This means that even if a user is allowed to access an object, like a profile or document, they might be able to change details or fields they shouldn't have control over. Example: in an online store, customers might be able to view and update their shopping address for an order. But what if the system also lets them change the order's total price or status, like marking it as shipped or delivered? If the system doesn't restrict access properly, a customer might change the price to something lower or mark the order as delivered without actually receiving it. Okay, so now it's time to talk about different approaches to implement authorization. There are the two most popular methods: authorization based on the token claims and authorization based on the external authorization store. And in this video, we will focus on these two. Let's first discuss authorization based on the token claims. In this scenario, we include authorization data in the ID and access tokens so the application or API can look into the token and make authorization decisions based on claims values. If we look on the left side, we can see that in the decoded token under roles claim, there is global manager role assigned. So now, once the application receives the set of tokens like ID token and access token, application can look into the ID token of authenticated user, can check roles claim, and can see that user is or user has global manager role assigned. And now, based on this information, application can make authorization decisions. For instance, authorization can decide whether to display specific section to the user or allow user to access specific functionalities. Let's talk about some important downsides of this approach. First of all, we cannot store complex authorization schema in claims. In the previous example, we have simple role names, like global manager. What about the situation where we want to handle complex authorization scenario, like user who is global manager can access documents but only from a specific department? With simple role claims, such scenarios become hard to be implemented. Large amount of claims can lead to large tokens, which should be avoided. And also, what about the situation when the role of the user has changed? In the ID and access tokens, we still have the old role until these tokens expire. Of course, we can obtain new token, but this will require contacting identity server or identity provider, and in some cases, re-authentication. This is not an ideal user experience. So, to summarize, authorization rules are business logic, while claims are just about the user's identity, and there is no business logic behind them. User's identity does not equal user's permissions. Of course, there are some exceptions. Sometimes we want to just include simple roles, like administrator or manager in the ID and access tokens. This will work fine if we know that these roles will not change very often and real-time validation is not so important. We can mix this approach with the authorization based on the external authorization store explained on the next slide. So now let's talk more about authorization based on the external authorization store. For more complex authorization rules, the better idea is to use external authorization, commonly called P*P architectures, or PIP, PDP, PEP. You can find different names. Let me explain this P*P architecture so you have more details. In such architecture, there are different kinds of applications. Those can be web applications, mobile applications, and the case is that access to those applications is secured by an identity provider, obviously. It can be Microsoft Entra, it can be auth0, any identity provider you can imagine. And now, obviously, those applications connect to different kinds of APIs. As we can see on the left side, there is financial API. And now what is important is the fact that within financial API, there is policy enforcement point, or PEP. And this policy enforcement point is the logic that is responsible for calling policy decision point, or PDP. So in this example, as you can see, once the user is authenticated, user sends request to see financial report for year 2023 to financial API. And now policy enforcement point is asking policy decision point, hey, can user X access report Y as global manager? And policy decision point, basing on the implemented logic and authorization rules, will make this decision. So we'll check whether user X has access to report Y. If access is granted, obviously user will be able to see this report in the web application or mobile application. But if policy decision point will return information that user is unauthorized or user cannot see the specific report, this report will not be displayed in any of those applications. An important fact is that policy enforcement point, or PEP, is only responsible for building like a simple request with the object and the resource that should be accessed by this object, in this specific context by the user. And policy decision point, or PDP, is the component that is making authorization decisions. So PDP has access to all those authorization rules, policies, and PDP will make decision whether a specific user can access specific object. And very important fact is that some identifiers are used here, obviously. So for the user, it can be unique object ID from identity provider, and for the report, it can be unique ID of the report. Let's provide a few more details about policy enforcement point and policy decision point so you understand their purpose in the architecture. Let's start with policy enforcement point, or PEP. It's a gatekeeper that checks if someone is allowed to access certain data or resources. When a request comes into API, the policy enforcement point asks another system called the policy decision point, or PDP, to decide if the request should be allowed. The policy enforcement point doesn't make any decisions itself. It just follows the rules provided by the PDP. You can find PEPs wherever important data needs to be protected in an application. Typically, policy enforcement point is implemented as a part of the API logic to make authorization decisions on each incoming request. Now let's talk about policy decision point, or PDP. It's a system component that makes decisions about whether users or processes should be allowed to perform specific actions or access certain resources based on predefined rules or policies. How does PDP work? To make it simple, there are 3 steps. First one, it receives requests. The PDP gets a request from the policy enforcement point, which is asking whether a specific action or access should be permitted. Then it checks the rules. So the policy decision point evaluates the request against a set of policies or rules that define who is allowed to do what. These rules might include things like user roles, permissions, relations, and conditions. And in the end, PDP makes a decision. Based on the evaluation, the policy decision point decides if the request should be allowed or denied and sends this decision back to policy enforcement point. Great, so now let's talk about some authorization standards to make it easier to implement architectures like this. Let me introduce you to OpenID AuthZEN Working Group. It's a collaborative initiative focused on improving and standardizing authorization mechanisms, particularly in the context of web applications and services. The group's aim is to address the challenges and complexities associated with authorization, which is the process of determining whether a user or system has the right to access certain resources or perform specific actions. Now, there is OpenID AuthZEN Authorization API. So the AuthZEN group proposed Authorization API 1.0 draft to make it easier to implement communication in P*P architectures. The Access Evaluation API defines the message exchange pattern between the client, so PEP or Policy Enforcement Point, and an authorization service, PDP or Policy Decision Point, for executing a single access evaluation. Here is the example of Access Evaluation API request. Let's discuss its structure a little bit. So, as we can see, there is a subject which can have specific type. In this case, it's user, and it has ID. ID can have different formats. In this case, format is issuer subject. We have issuer value, so identity provider who issued the identity to this user and this subject, and we have the subject value. And also, there is a resource, so the resource that user is trying to access, with type account and ID 1 to 3. And obviously, resource types can be declared in our system. It can be a report, it can be document, it can be whatever you imagine here in this specific scenario. There is also an action. So can user read this specific document? And the method get. It can be any HTTP method. And also important fact is that we can add context. So for instance, we can add time. And this is very important because we can make authorization decisions basing on context. So for instance, we can implement authorizations decisions like this. Can global manager access global reports outside of working hours? That's very important here. That's crucial. So as you can see, we have this access evaluation API request that will be sent to policy decision point, and then we will receive access evaluation response. And it's really simple. There is just one attribute, decision, true, false. Can this user access this specific document in this specific context, let's say? Yes, no, true, false. That's it. Okay, perfect. So to summarize, can user identified by subject value with this number access, or to be more specific, read details about account with ID 4531? The simple answer is true or false. With this approach, we can implement communication between policy enforcement point, or PEP, and policy decision point, or PDP. Perfect. So now let's talk about Okta Fine Grained Authorization. With Okta Fine Grained Authorization, we can implement architecture like this. So let's talk a little bit more about Fine Grained Authorization by Okta. It's a solution designed to handle fine grained authorization at scale. And here we have two options. We can either use OpenFGA, open source project that can be used for free. And in this specific scenario, we will have to host OpenFGA and configure everything ourselves. Or we can use SaaS product, Okta FGA. In this specific scenario, we don't have to worry about any infrastructure configuration. We can just start using the product. In this video, in my demo application, I use Okta FGA. Perfect. So that's about the theory. Now it's time to see it in practice. Let me start with the demo application. This is web application created with Blazor. Access to this application is secure with AuthZero. So when I click login button, I will be redirected to AuthZero login page, as you can see. Before I will authenticate, let me get back to application. This is reports application. So here I can display sample data about the reports. When I open reports tab, you can see that I'm asked to authenticate first. And when I access admin panel tab, I can see information that only system administrator can access this page. Perfect. So right now, let's open AuthZero dashboard so I can show you the users and their roles. Here is the AuthZero dashboard. And as you can see, there are two users. The first one using techminefactory@hotmail.com email, and the second one, Mauri. And now when it comes to roles, there is one role defined, administrator. The administrator role enables full management access for users. And now when it comes to users, the user with techminefactory email has this specific role assigned. So when we go to the roles, we can see that user with this identifier and with this email has administrator role assigned. And if I open another user, we can see that this user has no roles assigned. So it's just a standard user. Perfect. So now let's get back to application and see what will happen when I try to sign in with the standard account and access management tab. And then I will try to access the same application with the administrator account. Okay, so let's click login button. As we can see, we are redirected to the login page provided by AuthZero. And here I have to provide credentials, and now I'm successfully authenticated as Mauri, as we can see. If I access reports tab, now I have access to this page. Why? Because I'm authenticated user. And obviously here, I can type the ID of specific report. Let's do 12345. And let's click Get Report. And after a few seconds, we can see information. User is not authorized to see this document. It means that I'm not allowed to see document or report with the ID 12345. However, if I type 5 nines here and I will click Get Report, as we can see, I successfully retrieved information from the report's web API. This is a sample report data returned from the API, as we can see. Underneath, obviously, during the authentication, I have obtained access token to call report's web API. That's very important. However, when I click Admin Panel tab, we can see that nothing has changed. There is still information. Only system administrator can access this page. It means that this regular user without the administrator role cannot access this specific section of the application. So here we talk purely about authorization using claims. As you can see, we have this role claim in the token, and application is validating whether the ID token returned from auth0 for this specific authenticated user contains the role claim with administrator value. If user has administrator role, then user can access admin panel. If user doesn't have this role, user will see this information. Perfect. So let's click Logout button, and now let's sign in with administrator account. So again, I will click Login button. I'm redirected to auth0 login page. I have to sign in, but this time I'm using administrator account. And once I'm successfully authenticated, as we can see, as with another user account, administrator account, I can still access reports API. However, when I will click Admin Panel tab, you will see that there will be this redirection to auth0, and then I will be able to access this tab. Why this redirection? Because Admin Panel tab is using another web API, another resource. So under Reports tab here, we are connecting to Reports web API. And that's why we need an access token obtained from auth0. However, when we will access Admin Panel tab, we will be connecting to Authorization Management API, another web API. So that's why we need another access token. So let's click Admin Panel. And here we are. Admin Panel is available for us. And as you can see here, we have to type the user ID, so the identifier of the user, the identifier of the report, and we have to type relationship. And then we can click Create Relationship button, and underneath there will be relationship created between specific user, specific object, which is the report, with specific relation. Like for instance, can access, can read, can delete, and so on and so forth. And for that, we will use Okta Fine Grained Authorization. Before I will create any relationship here in this application, let me jump into Okta Fine Grained Authorization dashboard. Okay, so here is Fine Grained Authorization dashboard. It's available under dashboard.fga.dev. And this is the place where we can start defining authorization model for our application or solution. I will not go through all the details related to Okta Fine Grained Authorization. I'm providing the link in this video description. However, I would like to discuss some very important aspects of this solution. So first of all, Okta Fine Grained Authorization is using relationship-based authorization. So in this specific scenario, we are defining relationships between different objects within our system, like between users and resources. And before we can start using Fine Grained Authorization, obviously we have to register. For this, we can use our auth0 account. And once we have access to this dashboard, we have to create authorization store first. We can add new authorization store. As you can see, I've created one called Secure Reports. And once we have authorization store created, we can go through basically 4 steps. First one, we have to define our authorization model for our application, our solution. And for that, there is Model Explorer, which I will explain in a minute. And in the next point, we have to add authorization data. So basically information about those relationships between different objects and subjects. So like between users and specific resources, specific objects, like between users and reports in our scenario for this sample application. The next step is to write assertions, because we would like to check whether our authorization model is working in the way we expect it. So we are writing assertions and we can do some checks. And in the end, we have to connect our application. So this is why in our application, I had to integrate with Okta FGA .NET SDK, because it's a Blazor application and ASP.NET Core Web APIs. So in this case, I use .NET SDK to integrate with Fine Grained Authorization. Okay, let me click Model Explorer. This is the place where we define our authorization model. In this specific scenario, it's very simple, but believe me that you can build really rich and complex authorization models. Okay, so let me explain what's going on here. As you can see, I defined two types in this authorization model: type user and type report. Okay, and now for the report, I can define relations. So as you can see, a relation defines the possible relationship between an object and a user. So for the report, we are defining the following relations. Can access, so report can be accessed by the user or by the manager. Report can be created only by the manager. Report can be only deleted by manager. Data from the report can be read only by the user or manager, as you can see. Manager can update the report also, so regular user will not have this possibility. And also, we are saying that manager is also the user. Okay, so the manager here is also the user type. And I know that for now it can be confusing, but when I will show you the tuples, so definitions of those relationships, it will be more clear. On the right side, as you can see, there is a preview of this authorization model. Okay, so here, as we can see, I can check the definition of this authorization model. So user is defined in the secure reports authorization store. There is also report defined, okay? And now, as we can see here, user can be also manager, and we have those different relationships here in this graph. So, as we can see, manager can basically do everything here, okay? So manager can access documents, can delete those documents, but not all the users will have this possibility. And this is what I will basically show you in the next section. So when I open tuple management section here, as you can see, this is the place where I can define relationships between users and objects. So as you can see, I've already created some. So for instance, user 1, 2, 3, 4 can access, so we have this relation, can access the report with the ID 4321. And as you can see here below, this is the definition for the real users from auth0, so register in auth0. So as you can see, user with this specific object ID from auth0 is the manager and basically can access this specific report. And because of the fact that user is manager here, so relationship is set to manager, user will be able to do all those operations here defined. All those relationships are defined also for manager. So manager has all the permissions to do everything with the reports. Okay, perfect. So now let's try to add new tuple so we can understand what's going on here. Okay, so this is the place where we can define those relationships. As you can see, I've already created some, but let me delete them to make sure that we will start fresh and we understand what's happening here. Okay, so let's click Add Tuple. This is the place where we can define the relationship between user and object. So under the user here, I have to provide the unique identifier of the user. Then I have to select the object that this user will be in relationship. And obviously I have to provide unique identifier of this object. And then I have to define the relation. So let me first grab the unique identifier of the user. Let me get back to auth0 and let me copy unique identifier of the administrator user. Let me get back here, and here I will type user and I will add unique identifier of this user that I obtained from auth0. Then I want to say that this user is in the relation to the report with the ID like 1, 2, 3, 4, 5 to make it simple. And then I have to define this relation. So I want to say that this user is manager. So basically manager, as you remember, can do everything with reports like update them, delete them, create them, and so on and so forth. So here, once I click Add Tuple, this relationship is defined. So now user with this ID is manager to this report, in the relationship to this report, basically. So this user can do everything with this report, basically. Okay, perfect. And now let me add one more tuple, but this time let me get back to users and let me grab the ID of this standard user account. So for Mauri, so I will copy this, I will get back to dashboard, and here I will replace the ID for the user. And let's say that I will use the same report, but this time I'm saying that this user can just access this specific report. And I will click Add Tuple. Perfect. So as we can see, right now I have two tuples defined. One for the basic user with this ID, and this user can only access this specific report. And also I have another user defined here, which is administrator, and this administrator has a manager relationship to this specific report. So this basically user is the manager and can do whatever he wants with the report with this specific ID. Okay, perfect. So now we can test our authorization model. So when I switch to developer mode, this is the place where I have the overview of my current authorization model. I have overview of the tuples or relationships defined. And here I have assertions. Let me delete this assertion again so we can start fresh. And here I can create different assertions and test whether my authorization model works as expected. So let me click Add Assertion. And here, let's copy this user, this regular user, as you remember, not administrator user. And let's check if this user is in a specific relationship to this report. So let's check if this user can delete this specific report with this specific ID. And here we have to select expectation. So if this will be false, it means that this user with this ID cannot delete this specific report. So it's not in the relationship called can delete. But if we select true, it means that yes, this user with this ID can delete this specific report with this ID. So here I will set false and I will click Add Assertion. Perfect. So we can see assertion was successfully added. And right now here, I can click this Run Assertion button. So right now, as we can see, assertion is false here. And we can see that our authorization model works as expected. So this user cannot delete the report with this specific ID. Okay, perfect. So let's add one more assertion. This time, I will select can access. And I expect that the user with this ID can access this specific report. So I will change it to true and I will add this assertion. So right now I will click run assertion and again it works as expected. Perfect. So right now what I can also do, I can copy the manager ID, as you can see, and let's check if manager can delete this specific report with this specific ID. As you remember, because of the fact that user can delete report, like manager can delete the report, we should expect that this assertion will work as expected. So that's why we have this expectation set to true. So this manager user should be able to delete this specific report. Let me add this assertion. And here, let me run this assertion. Perfect. Green, green, and green. So here, our model, authorization model, works as expected. One more test. Let me again copy this regular user ID. And now let me check whether user can update this specific report. And I will set expectation to true. So I think that this user should be able to update this report. Let me add this assertion. Let me run it. And now, as you can see, it failed because this user, this regular user, cannot update the report with this specific ID. Perfect. So right now we can get back to application and see how it works from the application perspective. Okay, so we are back in the admin panel, and here under user ID, I will type the ID of the regular user, Mauri. And here I will provide the ID of the report. Let's say it's 9999. And here I will define the relationship. So can access. When I will click create relationship, what will happen underneath? This web application will call authorization API, authorization management API to be more specific, and authorization management API using the OpenFGA SDK will basically connect to my authorization store and create this relationship. So let's click create relationship button. And as we can see, relationship was created successfully. So let's get back to Fine Grained Authorization dashboard to see whether this relationship was created for sure. Okay, so here is the dashboard again. And as we can see, the relationship for this specific user and this specific report was successfully defined. Perfect. Let's get back to the application. Okay, so here I've opened Reports tab. And please note that I'm still authenticated as administrator user, not this regular user we added relationship for. So here I will type the ID of the report and I will click Get Report. And as we can see, user is not authorized to see this document. So even if I'm administrator, I do not have access to the report with this specific ID because this relationship was not created for this report in the Okta Fine Grained Authorization. So now let me log out and let me sign in as regular user. So here I will click login button again. I will sign in as Mauri, so the regular user. And then I will access Reports tab. And now let's try to type the report ID again. Let's click Get Report. And perfect. We can see that the data for this report was returned successfully from the Reports API. So authorization works as expected. So now it's time to see a little bit more technical details in the source code. Here is Visual Studio with all the projects that I created. So here is Blazor web application, reports application that we use to display reports and access admin panel. There is report web API created in ASP.NET Core to return information about the reports. There is policy decision point API, which is a separate API to make authorization decisions. There is Authorization Management API, which is responsible for adding and removing relationships between objects in our solution. And this API obviously is using Okta FGA SDK to communicate with Authorization Store. And there are two another projects, Infrastructure and Core. Infrastructure contains the configuration of Okta FGA SDK, and Core project contains some common components and classes used among those projects here. Let's start with report application and components. So here, under pages, I have reports page. And as we can see, there is authorized view. So I cannot access this specific view, this page, without the authenticated user. So that's why we saw this information. Please authenticate first. Once I'm authenticated, I can get information about specific reports. So if I scroll down here, important information is that there is getReportAsync method. This method basically is using HTTP client report API to call the endpoint of report API to get information about the specific report with specific ID. And obviously, if an authorized response is returned from the API, we display information user is not authorized to see this document. Simple as that. However, if we can access specific report, we will get just a simple information, read a string async, and we will display this information on the view. Okay, perfect. So now let me close that and let me open program.cs. Here I have a couple of services configured. Important information is that this application is secure with auth0. So that's why you can see here I'm using auth0 SDK for Blazor here. And I have to provide the configuration like domain, client ID, client secret. And also, important fact is that I want to obtain access token during user authentication, access token for report API. So that's why here I have to provide the report API scope. And last thing is that I'm using authorization here also, policy-based authorization here. So as you remember, to access admin panel, we have to be in administrator role, or we have to administrator role assigned to us. So this is the part here. So here I'm configuring authorization and I'm adding policy called administrator. What's going on here basically? So as you can see, we are adding claim requirement called administrator. And we have this claim authorization handler. So when I open it here, what it will do, it will look into the claims in the ID token returned from auth0. It will check for this claim, so basically roles claim. And if this claim contains administrator role, then it means that, yes, basically user is authorized to do specific things. So when we open the admin panel here, as you can see, there is authorized view policy administrator. So I will be able to access this page only if I have administrator role assigned in auth0. If not, we will see this information. As you remember, only system administrator can access this page. Okay, so now let's see what is happening in the reports API. So as you remember, I mentioned that from the web application, we are calling report API. And here I have this one method, getReportAsync. And here I have to provide report ID. Before any report is even, like retrieved from the database or any other source, I want to evaluate access. So this is important part about the authorization. So as you can see here, I have this policy enforcement point authorization service used with method evaluate access async. And what I'm doing here, I'm passing HTTP context and I'm saying, hey, check whether this specific user can access report with specific ID. So as you can see here, I have those constants. It can be really helpful. Common action values like can access, can read, can delete. And here, resource types for access evaluation, I have report. But if you have many objects in your system, you can define them also in this specific class. So let me expand authorization tab here and let me show you policy enforcement enforcement point service here. So as you remember, at the beginning in my presentation, I mentioned that typically policy enforcement point will be integrated within the API. And this is happening here. Policy enforcement point is not like a separate API, it's just a component within the reports API. And what's happening here? So as you can see here, obviously we have to obtain the access token to call policy decision point. And once we have the access token, we are sending this request to policy decision point API. Okay, so here we call evaluate access endpoint, and we are passing this information about the relationship and about the resource and about the user. And obviously we have the access evaluation response. And here, this access evaluation response, as you remember, contains simple true-false value. So decision. So if decision is true, it means that user can access this report. So here I'm just returning sample report data returned from API. But if decision is false, unauthorized response is returned. Okay, perfect. So now let's see what is happening on the policy decision point API. So here we have this one endpoint called evaluate access async. And we use policy decision point authorization service, in this case, to make a call to Okta Fine Grained Authorization. So we have this evaluate access async method here. We are creating authorization relationship object here. We have to provide the information about the relation. So for instance, can access, target resource, which will be the report ID, and user, which will be the concrete user from auth0. And here we use authorization engine manager dot check authorization relationship async. So this method is called, and this method, let me show you that really quickly. This method is using Okta FGA SDK. So it's very important to mention that there are multiple SDKs for different languages and frameworks. So here, as you can see in the authorization engine manager, I have OpenFGA client defined. And here I'm using this client to send the request to my authorization store to ask, hey, can user with this specific ID access report with this specific ID in this relation, like can access? And then Okta FGA will provide the response, true or false. So access evaluation response is returned here. Okay, before I will move forward, I want to show you one thing. I also mentioned at the beginning that there is this OpenID group called AuthZEN, and this group is working on the authorization API standards. And those standards are implemented here, as you can see. So we have this access evaluation request, as you remember. There is subject, resource, action, and context. And then under the subject, I have the type, so the user, the ID. ID is the ID from auth0. So I have all those details here. The resource, so report with specific ID. The action, so for instance, can access, and method is get. And context, like the time. So here I'm following all the standards provided by OpenID AuthZEN group. Okay, perfect. So now let me close this and let me get back to here, report API. So as you remember, if the decision returned from policy decision point is true, we return report data. If it's false, we return unauthorized. I also showed you that from the admin panel, we can add new relationship. So this is where authorization management API is used. This API has two endpoints, create relationship and delete relationship. And this API obviously is using Okta FGA SDK. So if I open implementation here, as you can see, I have this authorization engine manager, And here I have this create authorization relationship method. And again, here I'm creating the tuple, which I showed you in the Okta FGA dashboard. So I'm defining the relationship between user and object. So between user from auth0 and report with specific ID. Okay, perfect. Last thing I want to mention here is the fact that communication between all those components is secure with access token. So before I can call report API, I have to obtain access token in the report web application. The communication between report API and policy decision point is also secure with access token, but here I'm using a client credentials flow to obtain access token and call policy decision point. So policy decision point is called without the user context. Okay, that's very important. And also to communicate with authorization management API, I have to obtain the access token in the reports application, and then I will be able to call this management API. An important fact is that this authorization management controller has authorized attribute, but it's not only about the access token itself, it's also about the role, as you can see here. So obviously API will verify whether this token was issued from auth0, but also it will look into the roles claim to see whether user has administrator role assigned. So this is this, I would say, hybrid or mixed approach, which I mentioned before. So it's not, I'm not saying that, like having roles in the token is something bad. It just depends on the scenario, how or when and where you will use them. So in this specific scenario, only administrator users will be able to use this specific endpoint. And obviously granular authorization is implemented with Okta FGA. So basically here under infrastructure, as you can see, I have this authorization engine manager and it's using OpenFGA client. So all the authorization decisions are made against the authorization store I created in Okta FGA. Okay, perfect. That's it. I hope you enjoyed this video as much as I did, and I hope you found it interesting and helpful. If you would like to learn more about identity topics and secure application development in the cloud, I recommend checking my blog, techmindfactory.com. Maybe you will find some of those articles helpful for you. Thank you so much for watching and see you in the next video.